Okay, so hopefully a pretty quick lesson for you today. Actually, nothing new. We're just going to get a little bit of a chance to practice transcription and translation. And so today you will be creating a protein. Okay, just to reiterate what we've been talking about so far this week, the idea of the central dogma. Big idea in biology if you haven't picked up on that yet. This idea that DNA, which is the instructions for building the organism. Every single cell has a complete genome, that complete set of instructions for making the cell and every other cell in the organism, which is written in the language, right, air quotes, of DNA. From there, we're going to take that information and the pieces that are needed at the moment in order to make the protein, those genes are going to be transcribed or rewritten as a little bit more of a disposable copy called RNA. And then finally from there, the building process commences at the ribosome. The RNA template, the RNA instructions, which were photocopied from the DNA, are used to make the proteins, right? If we're thinking blueprint and photocopy, then the protein is the building, but really the protein is the functional thing that you're going to have within the cell. Cool. So today you guys are going to be figuring out a protein message and sharing that out with your class. To be able to do that, you're going to have to do a little bit of reverse engineering. So let me walk you through that process, okay? Remember that we start with DNA, and that is what you guys are going to be posting in the discussion post, is the DNA. And I want to point out a couple of things here, just logistical. To make your life easier, what I'm going to ask that you do is kind of follow a template that looks something like this. Take your DNA and break it into groups of 3 so that whomever is transcribing and translating it doesn't accidentally like get one off just on accident. It happens, right? So it's going to be a whole lot easier if you take your sections and break them into 3. It's going to be easier for others and it's going to be easier for you. And I also want you to number them. So each group of 3 is going to be numbered 1, 2, 3. Can you guess what's next? Yeah, 4. I hope you got that. But I know it's been a while since you've been at school, so maybe you forgot. Anyway, a quick note about this to make your life a little bit easier. Here is the exact same like text that I have above. I've just copied it and pasted it and changed the font into Times New Roman. And you see that the spacing is like completely wonky. To make sure that it shows up on your computer screen and on everybody else's, please do not do this. You want to use a font that is like equally spaced. So what I'm going to recommend that you do is use Courier, right? So all of your work you should probably do in Google Docs or Pages or Word if you have it, and do it all in Courier. It's just going to help you line everything up a whole heck ton of a lot easier. Okay, hecton, by the way, not a scientific term, but one you should probably be familiar with. Moving right along. So use Courier to do this whole thing. You'll make your life easier. Yeah, so we've got the DNA that gets transcribed into RNA. Wherever the DNA had a T, the RNA is going to have an A. Wherever the DNA had an A, you're going to have a U in the RNA. And then the C's and G's continue to match up. And then from there, you're able to go ahead and move into building a protein. Okay. Remember that in order to build a protein, you're going to take the information that you have from the RNA, and now you need to change languages. So we've been looking at nucleotides. We need to switch over to looking at the language of proteins or amino acids. So we're going to take each of these codons, groups of 3, and use a codon chart, voila, to do the translation. Right? So if we have AUG, we're using our codon chart here, and we're going to determine that AUG is going to code for methionine, AUC for isoleucine, etc., etc., etc. We can write that in the 3-letter format or in the 1-letter format. And in the case of the message that I wrote for you guys yesterday, First of all, I did mess up, so some of your messages are a wee bit off, and I'm grading that leniently. But what you should have seen is that I miss ya, stay safe. Okay, so I've had to get a little bit creative to write miss ya, stay safe, because there is no O or U. So I couldn't write like miss you. So again, I had to get a little bit creative, and you're gonna have to do the same thing. So you're making a message, then you're going backwards and identifying what is the RNA that makes that message, and then what is the DNA to make the RNA to make the message. So let me walk you through that process. In my case, I just kind of went around and looked at the codon chart and used the letters that are there to make my message first. Then I went through and figured out what codons, what groups of 3 nucleotides needed to be used to code for that particular amino acid. So for example, if I'm looking at M for methionine, to get to M, I needed to look at A, U, and then G, and that becomes my codon. To look at isoleucine or I needed the same beginning, A, and then U, and in this case, I chose to use C. From there, you'll go back a step further and change that into DNA, because that is what you're going to be posting. Now, I want to make a couple of quick comments about this. The message that I had happened to start out with methionine, and AUG is the start codon. I am not going to require you to start with the start codon. You can start with whatever amino acid that you want. Don't worry about it. And the other thing that I'll mention is you'll notice that isoleucine, this I right here, could be AUC, AUA, AUU. So there's a lot of different options that you have. Don't get bogged down. You can pick whatever you want, because the DNA that you make at the end is going to only have one option for the polypeptide that you make. Okay, so even though the polypeptide can have a whole bunch of different DNA sequences that make it, the reverse isn't true. So whatever you post as your DNA, there should only be one answer. There will be only one like correct answer that your classmates will be able to figure out. So moving on from there, what you are going to be doing is making a message at least 10 letters or amino acids long. So you're working backwards. You're going to start with the message, the protein, then figure out what the RNA sequence could be to make that protein, and then figure out what the DNA sequence would be to make the RNA that would make that protein. Cool? Cool. You're going to then go into the discussion board, which presumably you're already in if you're watching this video, and you're just going to post your DNA message. Okay, so, oops, my bad. As a reminder, please make sure that your message is looking something like this, broken up into groups of 3 and numbered, and put it into a font that is like equally spaced, such as Courier. Okay, so back here, good stuff, message, discussion board. Okay, post your DNA message, and I would recommend getting this out sooner than later, because then you're going to need to go back and respond to someone else's post. So if you post at like 8 o'clock in the morning, good for you. You're one of those morning people. I don't know how you do it, but whatever. So anyway, at some point you're going to have to return to this message board and respond to another post, and both of these are included in the same assignment. So I'm going to be looking for your DNA message and your response before I grade them. And so you have 2 choices. You can either take what someone else has done and decipher their code. So they've given you the DNA. Now you go through and determine what is the RNA and what is the polypeptide message. Just use the single abbreviations for the amino acids. If they're all taken, or if you just want to not do the first thing, you can go back in and rewrite their code. So figure out what is the polypeptide message and then reverse engineer to find a different DNA sequence that would result in the same polypeptide or the same message. Anyway, that's your assignment for today. I will warn you that Tomorrow's assignment will hinge upon you have finished this. So if you don't get this done today, try to get this done ASAP so that you're able to participate for tomorrow's lesson as well. If you've got any questions, let me know. If I didn't say this at the beginning, I have finally finished all of the Unit 4 assessments. Please take a look at those. Please take a look at your rubric and let me know if you have any questions. As I was going through, the same thought just kept repeating in my head, which is, I really wish we were back at school. I miss you all like crazy. I miss just like the class dynamics and how goofy y'all were, and I wish we could get back to it, but c'est la vie, that's life. Speaking of life, you get to play with some DNA and like create it on your own, kind of, sort of. So with that in mind, have a good night, day, whatever time you're watching this, and I will catch you on the flip side.